Record. So we're going to be talking about trig formulas, our last part. So we're going to finish the last example from last class. And then we're going to look at formulas like the double angle formula, the half angle formula, adding and subtracting using some formulas. So enjoy the last lecture. So here's where we left off. Did anyone look at this example? So so it's an important example, perhaps if you were flying a plane. So radar and air traffic control tower shows that the distance to incoming airplane is 7 kilometers and the distance to an outgoing airplane is 11 kilometers. So we can draw sort of a tower. This is my tower. It's an arrow. Yeah, sorry, I'm not sure how to draw a tower. And the distance here is 7, and here, let's say, is 11. The angle from the incoming to the outgoing airplane is 37. So this angle here is 37 degrees. Okay. How far apart are there two planes? What is this distance x here? It's not exactly drawn to scale or anything like that. So let me redraw it. So we have, let's say this is our 11. This is our 7. We're trying to find this distance, let's call it x. We know this angle here is 37 degrees. Okay, so which law are we going to be using? The sine law or the cosine law? Which law? Yeah, the cosine law, because we're trying to find this distance here. So law of cosines. So this x squared is equal to 7 squared plus 11 squared minus 2 times 7 times 11 times the cos of 37 degrees. We can solve for this. So this cos of 37 is approximately equal to, let's say, 0.8. So this will be equal to 49 plus 121 minus 154 times cos of this 37 degrees. We just compute this number. We get x squared is equal to approximately 46.8, which means x is equal to 6.8. Now, we're going to be talking about the double angle and half angle formulas. I will draw like a little picture, essentially, sketch over here. So we're considering, again, a right angle triangle. Like we normally do, we draw our triangle. This is a right angle triangle. I didn't draw it perfectly, but with this length 1 and this angle. So we're going to derive the formulas that I'm going to give it to you. So if we know this, we don't know theta, so this angle is going to be 90 degrees minus theta, which is equal to pi divided by 2 minus theta. So we're going to see sine of theta, and remember our SOHCAHTOA. So TOA over here. So this is going to be opposite over, so sine of theta is going to be opposite. Let me write that down. Over our hypotenuse. So our opposite over here, whatever that is. So opposite. And here we know this hypotenuse is 1. So if we rearrange this, we can solve for this opposite. So this opposite is going to be therefore sine of theta is equal to this opposite side. Whatever length it is. So this is, we can label this sine of our theta is equal to our opposite. So it kind of depends on how you draw your triangle and set this all up. But let's suppose this is the way you drew it. Now we're going to look at formulas like the double angle and half angle formulas. So the next step from this would be what happens when theta, this angle here, is 2 theta. We double the angle. So we're going to essentially take the mirror image of this triangle that we just drew across the horizontal side. That depends, of course, how you set it up to begin with. So I'm just going to redraw it again. Nice and large. Oops. Okay. So they're mirror images of one another. At least trying to. So we have theta here and we have theta here. And these are lengths 1 and 1. This is sine theta. This is sine theta. So we see here we have, I'll just color code it, 2 theta. Of course, we have 90 degrees. So that's all we're doing. We're drawing the same triangle and a mirror image because we're trying to examine what happens when we have this double angle. Okay, so I'll just kind of like repeat it one more time. So we have like this big triangle, basically like this now. Where we have one on this side, one on this side. And we could label like this one as A and this side is B. And because if we go back, we have sine theta and sine theta. Oops. So then this side is going to be 2 times sine theta, which is, let's say, our C, because it's 2 parts. And we're looking at what is this angle 2 theta. So we know by the law of cosines that this side, side C, so C squared is equal to 2 times sine theta squared times A squared. A is 1, so 1 squared plus B, that's another 1 squared minus 2 times AC, 1 times 1, times cos of 2 theta, this angle opposite side C, by using that law of cosines. So we're just applying the law of cosines. Now, I'll write it in the corner here. So it is important to notice that cos of 2 theta does not equal 2 times cos of theta. And this is why we're deriving the law of the double angle formula. Now, once we have this part, what can we do? Well, we can square and simplify and do what we normally do in math. So that means 2 squared is 4. Sine theta squared is the same as, we can just write it this way. Sine squared theta. 1 squared plus 1 squared, that's 2. Minus, again, 2 cos 2 theta. Now we could subtract 2 from both sides. Just bring this 2 on this side. So this would be 4 sine 2, or sine squared 2. Let me make it nicer. Subtract 2. Subtract 2 cos 2 theta. Divide by -2. So we want to divide by -2 because we want to get rid of this part here. So I'm just simplifying things. So this is +1 equals cos 2 theta. And then we could just rearrange it. So cos 2 theta is equal to 1 minus 2 sine squared theta. So this is one of the double angle formulas. Let's just put it in a box. So this is one of them. Put a little star. Let's call it 1. So again, so this is a double angle formula because so you take cos to find the double angle of theta, and it's 1 minus 2 times sine squared theta. Now we can replace. So we know, let me write a little note over here. Sine, our identity, our favorite identity, sine squared plus cos squared theta is equal to 1. We can just rearrange it like we normally do. So sine squared theta is equal to 1 minus cos squared theta. So we're going to go back here, replace sine squared theta with 1 minus cos squared theta. So we can go back and do that. So cos 2 angle is equal to 1 minus 2 times 1 minus cos squared theta so this is going to be 1 minus, and then we simplify, we bring in the -2 using our distribution property. So -2, negative, negative make a positive, so a positive 2 cos squared theta. Simplify. 1 minus 2, this is -1. I'm just going to bring the 2 cos squared in front over here. -1. This is our other angle. Let's put it in a box. So this is the second one. Okay. So we have another double angle formula. This is in terms of cos. The first one was in terms of sine squared. This is in terms of cos squared. Okay. Now from this part again, sine squared plus cos squared equals 1. We can replace the 1 here that we have by cos squared plus sine squared. So this therefore implies our cos 2 theta is equal to 2 cos squared theta minus, so we're going to replace this 1 by this cos squared plus sine squared, because that's equal to 1. That is the identity. So we just plug it in essentially. So let's put it in brackets. Cos squared theta plus sine squared theta. Okay. And now we kind of like can simplify, and we get cos 2 times theta is equal to 2 minus 1 is just 1. So this is just going to be cos squared theta minus sine squared theta. Let me put this one in another box. Oops. So these are the 3 double angle formulas for cosine. We just derive them. So these are the 3 double angle formulas. And we derive these formulas where theta is between 0 and 90 degrees. But these formulas are also valid for all real numbers theta. So for any number. So we have 1, 2, and 3. Now we can, and I won't do this, but we can use a similar approach to derive the double angle formulas that we did for cosine. We can also use it to find the double angle formulas for the sine function. So they're given here below. So the sine of 2 theta is equal to 2 cos theta sine theta. So it's important just to note that sine 2 theta again, does not equal 2 times sine of theta. Don't do this. Don't make that mistake. They're not one and the same thing. They're different. So don't think you can just put the 2 in front, because it's equal to this formula. Also for tan, the double angle for tan is this guy down here. And you can derive it sort of. Let's see. I won't derive it, but I'll just begin you the idea to the side. We do sine 2 theta divided by cos of 2 theta, dot, 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 and you get this. So we have sine of 2 theta up here, and you take the cos one, choose the right cos, and you will get the same answer as this eventually. Now, suppose that cos of theta is equal to 4/5. Evaluate 2 theta. So we're going to, of course, use the double angle formula. But which double angle formula do we wish to use? 1, 2, or 3? 1, 2, or 3? Whoops. Anyone? Well, we're given this. We're given cos. We're given cos. So the third one has cos and sine. The second one is just cos, and the first one is a function of sine. So you would pick, therefore, the second formula. So let's use the second formula. The second double angle formula for cosine. This is going to be cos of 2 theta is equal to 2 times cos squared of theta minus 1. And now we know what this is, so we can just essentially plug it in. So this would be 2 times, so this, remember, you can write it this way, cos theta, and then put brackets around it, all squared. They mean the same thing. We're squaring cos, minus 1. So this is going to be 2 times 4 divided by 5, because it's given in the question. Cos theta is equal to 4/5. We're squaring it, subtract 1. Now we just do the math. So this is 2 times 4 squared, so it's 16 divided by 5 squared, 25, minus 1. 2 times 16 is 32. Divided by 25, minus 1. So we can 32 divided by 25 minus 25 divided by 25. We're just commenting on meter like we did before. Yes, we have the 25 here. 32 minus 25, so 5, 6, 7. So this would be 7 divided by 25. So that is our answer. It's an exact answer. And it's just essentially choosing the right formula, asking yourself what it's given in the question. We're given cos, and then evaluating this. plugging it into the formula. What about this example? Suppose tan is equal, a theta is equal to 4. Evaluate tan 2 theta. Well, what is the formula for tan of 2 theta? I'll just write it down so you remember. 2 tan theta divided by 1 minus tan squared. Get the highlighter. Theta. So we're just going to essentially plug this in. So I'll just write it again. So tan 2 theta is equal to 2 times tan of theta, 1 minus tan squared theta. So this is 2 tan theta. I'm writing the same thing about 3 times. 1 minus, we can take the 2, put it around tan. It means the same thing. You could skip this step if you know it. Now we can just plug in tan of theta equals 4 into where, so 4 where tan of theta is. So that's 2 times 4 divided by 1 minus 4 squared. So 2 times 4 is 8. 4 squared is 16. So 1 minus 16 is negative 15. So that is our answer. So again, it seems complex at first, like if you just looked at the formulas, but it's not so bad when you just apply it, I think. I hope. There's half angles formulas for cosine and sine, and they follow from the double angle formulas. And then you solve for basically cos of angle. So let me do this on the page. So from before we had, so let's say from before or earlier, I don't know, we have cos of 2 theta is equal to 2 times cos squared minus 1. And this was the double angle formula. For cos theta. Now we're going to solve. So we're going to use this and we're basically going to solve for cos theta. So we can divide, the left-hand side by, and the right-hand side by 2. And first we want to move this over. So we do what we normally do. Cos 2 theta, you bring this 1 over. So it's going to be plus 1 is equal to And then we want to divide by 2 is equal to cos 2 theta. So then this implies our cos theta is equal to plus or minus square root of cos 2 theta plus 1 divided by 2. Now we could just replace theta by theta divided by 2. And then we would have cos of theta divided by 2 is equal to plus or minus square root of cos. Now this is 2, but theta is being replaced by theta divided by 2 plus 1 divided by 2. You see, like the 2's will cancel, and we got our answer here of our half angle for cos is equal to plus or minus square root of cos theta plus 1 divided by 2. So this is what we just derived right over here. So we just derived the half angle formula for cosine. So it's plus or minus square root of 1 plus cos divided by 2. And we can do the same thing for the sine function as well. And we choose the positive or negative formulas depending on your knowledge of your cos or your sine functions. So we just derived the cos one. You could do the sine one if you wish. So how do you know? So remember on the unit circle, if it's positive, we take the positive one. If it's negative, we take the negative one. So we tried on that unit circle to figure out if it's positive or negative. So we tried. So we can show like these steps. So find an exact expression for sine of pi divided by 8. Pi divided by 8 is like 22.5 degrees or something. So it's a little bit harder to find an exact expression. So we could take theta equal to pi divided by 4 and then apply the half angle formula. Then using the half angle formula, for sine, we get, so sine of theta divided by 4 divided by 2, we see that's going to be pi divided by, so pi divided by 4 divided by 2 equals pi divided by 8. We just kind of like plug it into the formula. Just checking the formula. One minus our cos, remember we took it's our angle to be pi divided by 4. So this is going to be plus or minus square root 1 minus, we know the cos of pi divided by 4. We've done this before. This is like square root of 2 divided by 2, all divided by 2. Remember, you're given a sheet. Now we know sine of pi divided by 8 has to be positive. So this means sine of pi divided by 8 is equal to, because it's positive, it's just the positive one we take. So it's going to be, we could simplify this too. We can multiply just the top the top and the bottom by 2. So this would be 2 minus square root of 2 divided by 4. So, and then because this is the square root, this whole thing, we could take the separate of the square roots. So this is just going to be equal to the square root of 2 minus square root of 2 divided by 4. So that's how you simplify this a little bit more, or no, divided by 2. So no one corrected me. 2, because you take the square root of 4 is 2, and then the square root of the top just moves over. That should make sense. I'll try to write this a little nicer. Whoops. So your final answer is square root of 2 minus square root of 2, all divided by 2. That's an exact expression for sine of pi divided by 8. We just found this exact expression. Okay, and there are half angle formulas for the tan function. Here, just give them to you. And if you wish, like just to kind of see how to get them, the tan of theta divided by 2, just going to be the half angles of sine divided by cos divided by 2 equals ... like these. And you choose these respectively to get the half angles of them respectively also, depending on which one you end up deriving. Okay, so let's evaluate tan of pi divided by 8. And let's find an exact expression. So when I say this, I say meaning finding an exact expression. Okay. So again, let's do a trick of take our angle to be pi divided by 4. This is just so that pi divided by 2 is equal to pi divided by 8. So we're going to use, let's use the bottom one. So using tan of theta divided by 2 is equal to sine of our angle divided by 1 plus cos of our angle. Might be like the easier one. So we obtain this tan of pi divided by 8 equal to sine of pi divided by 4 divided by 1 plus cos of pi divided by 4 equal to square root of 2 divided by 2. We know this, sine of pi divided by 4 is square root of 2 divided by 2. And our cos, so it's 1 plus, again, square root of 2 divided by 2. And then we simplify this. So we need a common denominator for the bottom. So that would be 2 divided by 2 plus square root of 2 divided by 2. The 2's can then cancel. Well, you could add these first if you wish. So 2 plus square root of 2 divided by 2. And this is square root of 2 divided by 2. Then cancel this and this. Then we are left with square root of 2 divided by 2 plus square root of 2. So that's our final answer. For tan of pi divided by 8 is square root of 2 divided by 2 plus square root of 2. So like there's lots of formulas, but these are the main formulas. The main, we just go back quickly. So the double angle formulas, these are the cos ones, the sine, the tan, and the half angle formulas. These are the main ones. There are other formulas. There's maybe like 20, but these are the ones that you use most frequently. There's adding and subtracting formulas. So here, put another box around this one. Oops. Wait. Make my box nicer. And you see that So again, it's important to notice that the cos of, let's say, u plus v, it's not equal to, so don't do this, make this mistake. It's not equal to cos of u plus cos of v. So do not do this. Now, if you want, as an exercise, try to derive this formula. So the cos of u plus v is equal to the cos of u times the cos of v minus the sine of u times the sine of v. If you don't want to derive it, it's okay. You don't have to. It's up to you. Now, let's write this formula again. The addition formula, because we're going to solve this example. For cosine. This is cos of u plus v is equal to cos of u times cos of v minus sine of u times sine of v. Find the exact value for cos of 75. So this is how to apply this formula. Well, we can't write 75 degrees in an easy way. So we could write those 75 with things that we do know. We know 45, we know 30. So we could therefore use 45 plus 30 equals 75. So we can then apply this cos formula. So you kind of break it down into something you do know. So because, let's write a little note. Because we know sine of 45 and sine of 30 and cos of 45 and cosine of 30. We're going to break it down this way. So this means that our cos of 75, it's equal to cos of our 45 degrees plus our 30 degrees. So therefore, our 45 is going to be our u, and our 30 is going to be our v. Now we have it in a format, we can just apply the formula. It gets a little easier now. So this means cos of u is 45. So cos of our u equals 45. So it's just basically plugging it in to the formula. Cos of v minus sine of u is 45, times sine, oops, I didn't need a bracket there. Sine of V. V is 30. So all we have to do, so we know the cos of 45, and you are expected to know these. They're given on the sheet. So the cos of 45 is the square root of 2 divided by 2. The cos of 30 is the square root of 3 divided by 2, minus the sine of 45, square root of 2 divided by 2, sine of 30 is 1 over 2. We can simplify. So this would be square root of 2 times square root of 3 divided by 2 times 2, 4, minus square root of 2 divided by 4. And we get square root of 6 minus square root of 2 divided by 4. So this is our final answer here. Now we can use symmetry properties of the cosine and sine to derive other useful angles, such as the difference between two numbers. So remember the addition formula was cos u plus v is equal to cos of u times cos of v minus sine of u, sorry, that's a u, times sine of v. Don't want to confuse anyone. So we want to find a formula for the difference. So to find a formula for the difference, what would we do? What do you think we do? Well, we have the formula where we add them, so we can just replace this v by negative v. That's it. So this implies cos of u minus v is equal to cos of u times cos of negative v minus sine of u times sine of negative v. So this implies here the cos of u minus v, and we're going to use properties. So using cos is equal to cos negative theta. This is because this has symmetry along the y-axis. And then we're also going to use sine of negative theta is equal to negative sine of theta. This is due to symmetry around the origin. Because of this, then we get cos of u times cos of v. Well, that's due to symmetry, so cos of v Now we have sine. Sine of u, that'll be the same. Times sine this negative, so the negative comes out. So this implies cos of u minus b is equal to cos of u times cos of v plus, because there's a negative and a negative, negative here, plus sine of u times sine of v. Just highlight that. Oops. So just notice there's a negative here and a negative here. This is why we got this positive here. So we just derived this. They're the same thing. So our difference formula, I'll just copy it down again. So our difference formula for cosine is cos of u minus b is equal to cos of u times cos of v plus sine of u times sine of v. Okay, so find an exact expression for cos of 15. So what do we know when we either add them or do something with them? You could say 20 degrees minus 5, but we don't know 20 degrees. We don't know 5 degrees. So that's going to be, so we don't want to really do that. And it's very normal if you don't know that, because I don't know what cos of 20 or cos of 5 is. So what do we do? So we could write 15 degrees as something we do know. So what do we know? What difference would give us 15 that we know, that we've studied? Yeah, so 30 would be 1, right? So 45 minus 30, right, is 15, right? So 30 would be something we know. So 45, we also know, minus 30, what gives us 15. So that's how you think about it. So then, using the difference rule, which we just I wrote quickly up there, using the difference. Formula for cosine. We obtain this. So the cos of 15 degrees is going to be the cos of 45 degrees minus 30 is equal to cos of 45 times cos of 30. I'm just plugging it in, plus sine of 45 plus times sine of 30. So cos of 45 is square root of 2 divided by 2. Cos of 30 is square root of 3 divided by 2 plus sine of 45, square root of 2 divided by 2. Sine of 30 is 1 over 2. Now we simplify. So this would be a square root of 6 divided by 4 plus square root of 2 divided by 4. So this is square root of 6 plus square root of 2 divided by 4. That is our final answer. Now there's similar formulas, of course, for the sine function as well. There's these. If you wish, you can try to derive these formulas. It's up to you. So there's the sine ones. And you see that there's when you're adding, there's a positive here. So it's sine u cos b plus cos u sine b. And the difference is sine u cos b minus cos u sine b. But let's find an exact expression for sine 15. So again, what are we going to do? What is our u and our b going to equal to get 15? The question we ask ourselves, because we don't know the sine of 15. So what would we choose? So we can write 15 degrees as 45 degrees minus 30 degrees. Then, using the difference for sine, for the sine function, we obtain so sine, let me just write this, what the sine is, difference up here. Sine u cos b minus cos u sine b. So using this, we obtain the sine of 15 degrees is equal to sine of 45 minus 30. They're the same thing. And now we can just plug this in because we know what our u is. Our u is this and our v is this. So we have sine. So I'm just plugging it all in. Just ran out of space, so I'm gonna try to write nicer. Now we know the sine of 45. Again, it's square root of 2 divided by 2. Cos of 30 is square root of 3 divided by 2 minus cos of 45. We know it's square root of 2 divided by 2. Sine of 30, 1 over 2. And we can compute these. And simplify. So we get our final answer right here. And so square root of 6 minus square root of 2 divided by 4 is our final answer. But once you set it up, it's essentially just plugging it in and simplifying. You can, of course, also find other formulas for the tan function. So tan is equal to sine over cosine, and you could rearrange, but we won't get into that. Now, there's transformations of trig functions. So there's a quick, so we're going to revisit those transformations that we did a long time ago, many weeks ago, that we might have forgotten. But if we remember what so there's a definition of the amplitude. So this is basically 1/2 the difference between the max and the min values of a function. Or, so like there is this definition. So suppose we have the sine function or the cosine function. Let's draw that one instead. So it goes from here down like this. This is our cos. So it starts at 1 to -1. Should do it a little nicer. So the amplitude is just from, now it says it's 1/2 the difference from the max or the min. So that would be like 1/2. Or I also think of it as from the 0 point to this point. This is also called the amplitude. So from that 0 to that point. Let's put the 0 there. So the amplitude of the cosine function or the sine function is therefore 1. You can see that is from the 0 point to 1 or 0 to -1, that difference is 1. Or by this definition, it's 1/2 the difference between the max, which is 1, and the minimum, which is -1. That difference is 2 divided by 2. So it's the same kind of definition. So find the amplitude of 3 sine x. So as we sort of maybe remember from a while ago, 3 sine x is just sine x stretched vertically by a factor of 3. So let's draw this. So we have pi divided by 2, and negative pi divided by, wait, over here, no, sorry. It's not drawn perfect, like to scale. Negative pi divided by 2, negative pi, something like that. And so the sine function, the maximum is at pi over 2. But let's say we're stretching that point, or multiplying that 1 by 3, so it goes up, like let's say 1, 2, 3, so it goes up here. Then the same thing for the bottom, be negative 3. And goes through pi and 0. So those are still just points. So the idea, let me just draw this. The amplitude here is 3. So this is our max value, 3. We could, of course, extend it. So now remember that the sine and cosine functions are both periodic and they both repeat at 2 pi. So like their period is 2 pi. So that means that the sine of x is equal to, we can add multiples of basically 2 pi, 2x, because like they repeat. And the same with cos. 2 pi can be added to x, and it's just going to be the same number. It's going to be repetitious. Also, tangent function, if we remember, is periodic with period pi, as we remember that. So sketch the graph of 2x, and what is the period of cos of 2x? So let's kind of draw this. Let's make a little note. So the cos of 2x is just like cos of x. With the graph being shrunk horizontally by a factor of 2. Okay, so Let's draw like a little sketch of it. Doesn't have to be perfect. I'm just making some labels here on the axis. Okay, so we're looking at cos. So we know when x equals 0, 0 times 2, well, that's going to be the same value. It's equal to 1 here. What about, so when cos of pi over 4, so pi over 4 times 2 times pi over 4, this is equal to 0, this value. Or, yeah. Here, at this value, pi over 2 times 2, that's pi, cos of pi. So this is -1. And we can plot like these points, but you see that it basically shrinks it. Or, yeah, this way. Then you get the idea. So let me make some notes. So the period of cos of 2x is, well, we can see from drawing this, you start, let's say here, it's when, so the period is when there's one full cycle. So you can start anywhere on the curve, it doesn't really matter, but let's pick here. So you go up and down. So this would be the period, this distance. So this period is equal to, well, negative pi divided by 2 to pi divided by 2. That is equal to pi. So then the period is therefore pi. Now you could think of it like 2 pi, like a pattern here, because the period is normally 2 pi, but now we're dividing it by this factor here of 2, which is pi. You could pick different points on this. You could pick up here to this point here. This would also be, the period would also be pi. Because remember, the period is where the, it's where it completes one full cycle. So it's like being on a roller coaster. You pick a spot, and then where does it come back to that same spot? So you pick, let's say you're at the top, you go down, go back to the top. So, and then you go from 0 to pi. So that would be your period. I'll just make a few more notes here. So this is where the period, remember, of cos of x was equal to 2 pi. So in general, we noticed a little bit of something that just happened. So in general, the period of cos of, let's say, kx, because this is like in the form of cos 2x, where our k was 2, is equal to 2 pi divided by k. So we kind of like have a kind of a general formula for this. Now we remember like horizontal shifts, like let's say f of x minus a is a shift of a units to the right, and f of x plus a is a shift of the function a units to the left. When we're talking about trig and cos and sines, we referred like these horizontal shifts as basically the phase shift is how we phrase it. Because basically trig function, it's still a function, and what were the arguments inside of the cosine or sine functions, when we shift those, we refer this as the phase shift. So the sine of x plus pi divided by 6 is just the sine function shifted left by this pi divided by 6 units. That's all it means. So it's just a shift left. So this is like your A, so to speak. A useful thing to remember is the sine of x plus pi divided by 6 is cos of x. We did this before. Sorry about that shift. As an exercise, if you wish, you could draw the graphs of sine x plus pi, let's say, divided by 2, and cos of x on the same coordinate system. To check that sine of x plus pi divided by 2 is equal to cos of x. I'll leave that to you if you wish. So this is the end.